Today's notes, we're looking at trapezoids and kites. So a trapezoid, T-R-A-P-E-Z-O-I-D, is a quadrilateral with exactly one pair of parallel sides. The two parallel sides are called the bases. So here's my two parallel sides, and they are both bases. So there's two bases in a trapezoid. The two non-parallel sides, that's these two, are called legs. A pair of base angles share a common base. So 3 and 4 are a pair of base angles, and 1 and 2 are a pair of base angles. In any trapezoid, the mid-segment, which is the one that bisects both of the legs, is parallel to the base. The length of the mid-segment is half the sum of the bases. So here's a little formula. Mid-segment, MN, in this picture right here, is equal to 1/2 of the sum of the length of this plus the length of that. Okay, so we're going to find GH in each trapezoid. So here's my trapezoid. Again, this distance is equal to 1/2 the sum of these two. So I'm going to take the 3x minus 6, that's not an equals, minus 6 equals 1/2 the sum of the two bases. Okay, and then I'm just going to solve this. So I'm going to multiply everything by 2 to make that 2 go away. That's going to give me 6x minus 12 equals 2x plus, it's a minus 1. This is a minus 1. 2x plus 24. So minus plus 24. Then I'm going to add or subtract 2x from both sides. That's going to give me 4x minus 12 equals 24. Then I'm going to add 12 to both sides. That's going to give me that 4x equals 36. So I'm going to divide both sides by 4. And that's going to give me that x equals 9. Then to find GH, I substitute this in there. So I'm going to go 3 times 9 minus 6, which is 27, minus 6, which is 21. So GH equals 21. Okay, you try. Pause the video. Come back. Did you get GH is 13? If not, you need to ask me about it when you come into class. Okay, the next part of our notes is about an isosceles trapezoid. We've had isosceles triangles. Isosceles triangles are the triangles that have two legs that are the same length, right? And that gives them congruent bases. It's one of our theorems. So in an isosceles trapezoid, it's a trapezoid where the legs are congruent. So it's the same idea, but it's a trapezoid shape. As an isosceles trapezoid has special properties. According to theorem 619, the base angles are congruent. So my sides are congruent, my base angles are congruent. And the diagonals are also congruent. So remember though, this is not a parallelogram. It only has one set of parallel sides. These two sides are not congruent. Okay, with that information, I'm going to find the measure of the numbered angles in each of these isosceles trapezoids. So the first thing to do is identify which angles are congruent. So these are the parallel lines. That means these angles right here are congruent to each other. So the base angles are congruent. So angle 1 is congruent to the 58-degree angle. Angle 3 and 2, or 2 and 3, are supplementary angles to 58. So these two angles are going to add up to 180 degrees. So angle 3, measure of angle 3, the measure of angle 3 is equal to 180 minus 58. So that's going to give me that the measure of angle 3 is 122. I'm sorry. Yes, is 122. So that's the measure of angle 3. with that information, I'm going to follow the same process to find the angles in this one. So these are my base angles. So that means angle 1, the measure of angle 1, is 109 degrees because it's congruent to this one. I'm sorry. Let's try that again. These are my bases. Oh yeah, measure of angle 1 is equal to 109. The measure of angle 1 is equal to 109 because these are congruent. These are also congruent. So these two angles plus these two angles equal 360 degrees, but the consecutive angles are supplementary, right? So the 1 and 2, angles 1 and 2, are 180 together. So this angle is going to be 180 minus 109, which is 71. And that means this angle right here is also 71. Okay, so you try. Did you get 136 for angles 1 and 2, and angle 44, or angle 3 is 44 degrees? If not, you're going to want to ask me about it. Okay, the next thing we're looking at are kites. So kites are, they're quadrilaterals. They're quadrilaterals in which two pairs of consecutive sides are congruent and no opposite sides are congruent. So consecutive means in order. So these two are congruent. These two can't be congruent because these are opposite sides. So it prevents this from becoming a square or a rhombus. So in a kite, the diagonals are perpendicular, and the diagonals look like a crossbar in the frame of a typical kite that you fly. So, you know, when you see your kite, regular kite flying, it has this crossbar like this. Notice that the sides of a kite are the hypotenuse of a right triangle. So these right here is the hypotenuse of triangle FKJ, because this is a right angle right here. And the legs themselves are formed, the legs right here are formed by the diagonals. So we're going to use that information, and we're going to find the missing information in these kites right here. So in this first one, to start, since the diagonals of a kite are perpendicular and the angle measure of a triangle add up to 180, I'm going to write an equation for the measure of angle 1. So the measure of angle 1 plus this angle, right, they needed a perpendicular, so that's a right angle. So 1 plus 90 degrees plus this angle right here, which is 18, is 180 degrees. So then I simplify. Adding the 90 and 18 is going to give me 108. And then I'm going to subtract that 108 from both sides. And that's going to give me that the measure of angle 1 is equal to 72 degrees. Okay? Now, this is 72 degrees. So how do I figure out this one? Well, let's look at our triangles. Notice that I have a hypotenuse and a leg, and in a right triangle, right? The hypotenuse and leg tells me that I have the hypotenuse and leg. That means these two triangles right here, this one and this one, are congruent, which means angle 1 and angle 2 are congruent. So angle 2 is 72 degrees as well. Okay, looking at our next one. This picture right here, I have a triangle. I'm going to draw it in a triangle to help clarify some things. So the first thing I'm going to do is I'm going to draw in my diagonal. I'm going to use this color pen so it doesn't like cross everything out. So this is a side, right? This side, and the one they share. So by side, these two triangles are congruent. That's going to give me that angle 1 and the 110 degrees are congruent to each other. So the measure of angle 1 is 110. Okay, then this is quadrilateral, so the four angles all add up to 360 degrees. So I have my 360 degrees. I I'm going to subtract my 110 and my other 110 and my 98. And that's going to give me 42 as an answer. And that's going to equal the measure of angle 2. Okay, so again, I knew this because these two triangles are congruent, so the corresponding parts, the CPCC right here, makes the angle 1 congruent to the measure of the 110-degree angle. And then because the interior angles of a quadrilateral are 360 degrees, I know that this angle is the 360 minus the other 3. That's where this equation came from. Okay, now looking at this one, these are tricky. You really have to look at what you have. So I'm looking at this, I'm thinking, do I draw a diagonal? What do I do? And then I realized that this triangle right here has the same side lengths, which makes it an isosceles, which makes this angle right here 54 degrees. So angle 2 is 54 degrees. And then again, I have isosceles triangle, and that means the angle 1 and 70 degrees are the same. So the measure of angle 1 is 70 degrees. And then to find this third angle on both the triangles, it's going to be 180 minus the doubling of the value of the base angle. So it's going to be 180 minus 108, which is 72. And this one's going to be 180 minus 2 times 70, which is 140, which gives me 40. So the measure of angle 3 is 72 degrees, and the measure of angle 4 is 40 degrees. I want you to give that one a try. If you have any questions, make sure you're writing them down. We'll talk about them in class. Did you get that? Did you get that the angle of measure 1 was 90 degrees, number 2 is 35, measure of angle 3 is 35, measure of angle 4 is 28, and the measure of angle 5 is 62 degrees. If you did not, you want to talk to me about it. We'll identify the triangles and the pieces that allow that to happen. Okay, that's it for trapezoids and kites. See you in class.